Yeah, greetings all, and this video we are going to talk about this function, and the question reads: the curve y equals this function passes through the points half comma 7 upon 2, and this first derivative, like this f prime f, equals to e raised to power 2x minus 1. This is what is given to us, and what we are required to find here. The first part says find the equation of the curve, which is the first part, and the second part says value of this second derivative, that f double prime of x equals to 4. So we are required to find the value of x when this second derivative is equals to 4. You see, given your answer in the form a plus b ln square root of 2, where a and b are constant. This is what we are required to find. So we are given this, and the first part we are required to find simply the equation of the curve, and the second part we are required to find the value of x given the relation or the equation. You see, and what we are going to have at the end of the day for value of x must be in this form, which is a plus b ln square root of 2. This is what we are required to find. So if we start straight, we consider the curve given, say solution. So we are given the curve, say given the first derivative f prime of x equals to e raised to power 2x minus 1. So we are given this. We are required to find the equation of the curve. And the equation of the curve is the derivative. So we have to move from this derivative to the curve to the function. So moving from derivative to function, it simply means we apply the integral form. So if we integrate on both sides, so take the integral of f of prime of x dy equals to the same thing again. We'll do it on the right, the integral of 2x minus 1 in terms of dx. This is what we have. So if we integrate on both sides, if we integrate this function, so it's going to be y equals to, if we integrate this function, we have to integrate the power. If we integrate 2x is 2, and if we differentiate 2x is 2, minus if we differentiate 1 is 0. So the differential of this power 2x minus 1 is going to be 2. So since we integrate, we divide, so it's going to be half. We write the function e raised to power 2x minus 1. And since there are no limits, so we end up having a constant, which is c. This we have. So our first point here is we are required to find the curve. This should have been the curve, but we don't know the value of c. Since we don't know the value of c, we quietly move on to find the value of c. How can we find the value of c? We are guided. We are given the points for both. We are given the points for this curve, and the point is given as this. X is 1 upon 2 and y is 7 upon 2. We substitute the value of y and the value of x. We have the value of c. Having the value of c, you slot that will give us the curve for this equation. So if we do that, we say y is 7 upon 2, we slot that 7 upon 2 equals to, because this, if we differentiate this also can be the function, it's the same thing, the function, because if we differentiate, we're going to give a function. We can either write y or f of x, the same thing. Yeah, but this function, this f of x given as 7 upon 2, or y is given as 7 upon 2, and value of x is given as half. So say 7 upon 2 equals to half e raised to power 2. But the value of x here is half, so slot that half minus 1 plus c. So we maintain 7 upon 2 equals to half. 2 times half is 1, so going to be 1 minus 1 plus c. So this will be 7 upon 2 equals to half plus c, because 1 minus 1 is 0, e raised by 0 is just 1, so this. So suppose 7 upon 2 minus half equals to c, so this gives us the value of c to be 3. So in this case, the function now, f of x becomes, half e raised by 2x minus 1 plus c, and c is 3. So this is the first part of the question. We are required to find the curve. The curve for this equation is f of x equals to half e raised by 2x minus 1 plus 3. This is the curve. And if we move to the second part says find the value when this equals to this, you see. And the value of this, simply we are required to find the value of x for which this second derivative equals to this. For us to find the second derivative, we recall from the first derivative. We say we record from f of x, and this first derivative given as a raised to power 2x minus 1. So we can use this first derivative to find the second derivative. So if we differentiate this with respect to this, it's going to be the second derivative of x. If we differentiate this, we differentiate the power. If we differentiate 2x minus 1, it's going to be, or 2x, it's going to be 2. Because if we carefully differentiate 2x minus 1, it's going to give us 2. So that's 2, multiply it to the function, which is 2 times 0 over 2x minus 1. But we are given, we are given f double prime of x to be 4. Look at it here. F double prime of x equals to 4. So this stuff is going to 4. So this one is going to be 4 equals to 2 e over 2x minus 1. This is what is given to us. So if we continue, so this will be, we say 4, we'll divide both sides, so going to be 2 equals to e over 2x minus 1. And we introduce ln on both sides, it's going to be ln 2 equals to ln e over 2x minus 1. So this is going to be ln 2, it's going to be 2x minus 1 ln e raised to power 1. You see, this is what we are. But we have to take note of that. This ln e raised to power 1 is equals to 1. So we have ln 2 equals to 2x minus 1. Our target is to find the value of x. So it implies 2x equals to ln 2 plus 1. Divide both sides. X will be ln 2, half ln 2. X will be half ln 2. So the value of x here will be half ln 2 plus half. So if we move that value, so we are going to have x equals to ln 2 raised to power half. We'll move this power to this 2 and plus half. So x will be ln this half, we can write as root 2 plus half. So we are required to write it in this form. So therefore x now is going to be half plus ln the square root of 2. This is the function. Where in a will be half and that of b is, coefficient of b is 1. So this is this. So this is just the basic step. So thank you. Please subscribe, like, and give your comments. Thank you.